Alright, now let's talk about angles in standard position. Okay, so a few definitions. First one is like the terminal arm. So this is basically like when we have one angle here, or one arm here and one arm there, basically starting at the origin and at y equals 0, and then the other one moving to whatever the angle is. If a question asks you for coterminal, this is all the other angles that would be in the exact same position. For example, if we have an angle of 35 degrees, basically if you were to add 360 degrees, so make it like 395 degrees, it would be in the exact same spot. So to figure this out, you can always just add 2 pi or 360 degrees. Next is the reference angle. So this is the acute angle from the terminal arm to the x-axis. For example, if we had this 35-degree angle, the reference angle is 35. But if we have a 145-degree angle, so that's going to be from here to here, the reference angle would be 35. We would take the 180 that we would have from here, and we subtract like the 145, and we're left with 35 degrees. If we have, say, 215-degree angle, then that would mean that we have 180, which is just flat, and then plus 35. So the reference angle itself would just be 35. It's always an acute angle between 0 and 90. And also, just notice that like 215 degrees would be in quadrant 3, and the way we number quadrants is 1, 2, 3, 4, and basically quadrant 1, both are positive. In quadrant 2, x is negative, y is positive. So basically the sine is positive, cosine is negative. In 3, both are negative, and in 4, sine is negative, the y. Okay, so let's try this example. Determine the other angles between 0 and 360 degrees that have the same reference angle. Okay, so let's draw this. So 116 degrees is right here, roughly. And we know that the reference angle would be this area right here. So to figure that out, we just go 180 minus 116, and we will get 64 degrees. So to have a reference angle of 64 degrees, that's going to be one option. Another option would be if we had our angle here, 64 degrees, or like this, 64 degrees, or like that, and this one is 64 degrees. So the answer to the question would be 64 degrees, that's our first one. 116, which is like the original angle, because that also has a reference of 64, this one. 244, so you would take 180 and you would add 64 to figure out this one. And then lastly, this one right here. So that's going to be 360 minus 64, and that's going to give us 296 degrees. So that is our answer. Okay, let's try this. So the point 2, 5, or 2, let's do negative 5, lies on the terminal arm. Determine the primary trigonometric ratios and the angle to the nearest degree. So 2, 5, let's say 2, and then negative 5, so the point is here. So what that tells us is that this is 2, this is negative 5. We can solve for the hypotenuse by just doing a squared, b squared is c squared. So 2 squared plus minus 5 squared is equal to the hypotenuse squared. So it's going to be basically 29 is equal to 8 squared. So we'll just say h is equal to root 29, because you can't simplify that. And then the three ratios would just be sine, cosine, tangent. So sine theta would be equal to the opposite over the adjacent. So if we are saying that this is the or side would be opposite over the hypotenuse. So if we're saying this is the theta, then it's going to be minus 5 over root 29, which we can rationalize by multiplying by root 29. And I'll just make some space. So that's going to be equal to negative 5 times root 29 over 29. Cosine would be the adjacent, so 2 over the hypotenuse, which will also be rationalized. So 2 over 29 to just get the denominator with no roots in it. And then tangent will be equal to the opposite, so minus 5 over 2. And then to find the degree, you just use, like, say, inverse tan or one of those ratios, and then just plug it in, and you'll get negative 68 degrees. And that is the reference angle that you'll get. So then you would do 360 degrees minus that. So that's going to be 292 degrees. So that's this one.